So there's some rain predicted today. Before I left my house to make this video, I checked the chance of rain and 90%. But what does that mean? Does that mean that over the next hour it's going to rain for 54 minutes? Or that over an area of 100 square kilometers it's only going to rain over 90 square kilometers? Or does it mean that over the last 100 years on this very day only 90 of them had rain? What does chance of rain even mean? The technical term is probability of precipitation because precipitation can come in many forms. And one of the many problems in trying to understand this number is that different weather services have different meanings for it. Okay, so let's say that you open up your weather app and it says there's a 50% chance of rain. What it does not mean is that it will rain for 50% of the day or that it will rain over 50% of the region. This number will also not tell you how much it is going to rain. If it says 100%, it doesn't mean there's going to be torrential rainfall, as you can see. What it does mean is the likelihood that it will rain at any point you select in a certain specified forecast area. It's a combination of two factors: how likely it's going to rain and how much of the region might experience rain. So, for example, from the American National Weather Service, their definition is that it's a product of two factors, C and A. C is the confidence that it will rain somewhere in this specified forecast area, and A is the percentage of the forecast area that will receive a certain measurable amount of rain if it rains at all. So if I say a 50% chance of rain, it could either mean that the forecaster is 100% certain that 50% of the forecast area will receive some amount of rain, or the forecaster is 50% certain that the entire forecast area will receive some amount of rain. Now, why these two factors are strapped in with each other, I don't really know. Probably because meteorologists thought that this is the best number that gives us some idea about what's about to happen. But what is this likelihood business? Isn't the whole point of science to tell me very concretely, is something going to happen or is it not going to happen? Well, turns out A, that's not how science really works, and B, that's not how the universe works. The problem here is that weather is inherently chaotic. What that precisely means is its own can of worms. But here, the idea is that even if I can accurately describe how the clouds move using some somewhat basic physics, it is impossible to predict what the future will look like based on current information, because we cannot measure the current state of the climate with infinite accuracy. You can try to approximately define what today looks like, but that means that your predictions or forecasts will only approximately be correct. And importantly, the further into the future you look, it would look exponentially different than what actually happens. So, to combat this, atmospheric physicists and meteorologists use some pretty advanced mathematics and physics to come up with various models to describe weather patterns. And then they try to collect as much data as possible and then run these models using that data as an input. Now, every model is born a little different, so they will produce different results, but in the beginning they will all share similar features, and they start deviating only about 5 days into the future. So you can average all of that out, and that will give you a pretty rough idea of what life is going to look like. You might have seen this through something like hurricane forecasting, where they use various techniques too. Instead of giving you a fully specific track that the hurricane will follow, and rather show you like a wide range of possibilities that a hurricane might follow. Another problem with this definition is that while all meteo organizations around the world somewhat broadly agree that it should be the product of, the confidence that a forecaster has that it was going to rain somewhere in a region and the percentage of the region that will receive some rain, what is some rain? How do you define some rain? What is the minimum amount of rainfall required for you to say there is rain? And unfortunately, this is where all these meta organizations differ wildly. The National Weather Service defines it as probability that more than 0.01 inches or 0.25 millimeters of precipitation will fall on a single spot during a specified time period, averaged over the forecast area. And from this, it defines two quantities that have been normalized over two periods of time: 6 hours and 12 hours, called POP6 and POP12. The NOAA, which is like the NASA of the space and the ocean, similarly defines it as the probability that the forecast point in question will receive at least 0.01 inches of rain. Environment Canada sets the boundary at 0.2 millimeters of rain or 0.2 centimeters of snow, and the UK Met Office reports the same number but rounds it to the nearest 5% with a minimum threshold of 0.1 millimeters. So just so we're on the same page, 50% chance of rain as reported in the UK requires a lower threshold than 50% chance of rain in the US. Thanks? The reason why POP is defined as it is because it is trying to be reductive. It's trying to encapsulate a lot of complexity into a single number. But as a consequence, it actually becomes a lot more confusing for the end user, and that can have some terrible consequences. Here's a problem with talking about science in terms of likelihoods and probabilities and uncertainties. As the pandemic has abundantly made it very clear, it is very hard for people in general to comprehend uncertainty. And this includes me, right? Like, I'm not trying to be like holier than thou or anything. Whenever someone talks about probabilities, we always recast it in our minds in terms of certainties. If I tell you that the odds of getting heads in a coin toss is 50%, you would think that if I tossed 2 coins, then one of them will definitely be heads. But that's not what the number really means. This probably arises from this general human tendency to either ignore uncertainty entirely or take it as absolute certainty when it comes to decision making. Where have I heard this before? This can have some serious consequences for people who live in meteorologically perilous regions, shall we say. For some reason, it has been shown that they almost expect a kind of periodicity in the disasters. Like, okay, so there was a cyclone on the 15th of December last year, so there's going to be a cyclone on the 15th of December this year. You know, which, okay, probably this works well enough as a kind of rough approximation, but weather and climate are way more chaotic than that, and it doesn't mean that a cyclone can only happen on the 15th of December or even the middle of December. It can theoretically happen at any point in time. It's just sometimes it is pretty likely that this happens in December. The point here is the miscommunication between meteorologists and the common folk like myself. And a study was actually conducted in figuring out exactly where this misunderstanding happens. Link in the description. This arises from confusion regarding the reference class, what the statement signifies, and how we are supposed to interpret these statements. And because it comes to weather stuff, these errors in judgment were based on the decisions that people made after reading the statements and not necessarily their understanding of the statement itself. Because, okay, think about it, right? When you're looking at your weather app and you're checking the temperature, you're not doing it out of scientific curiosity. The number 22 degrees Celsius doesn't really mean anything. But the reason why you do it is because you have to make decisions about, for example, what to wear. Should you wear a hoodie? Should you wear a cap? Should you wear some shades? Whatever. And the only time that these errors, as measured in the study, did not exist was when the forecast said no chance of rain. And, you know, you can't really get more certain than it's not going to rain. Now, of course, there might be a sampling error because this is a university study and the sample that was studied were all college-educated people in a region of the United States that rains a whole lot. But the researchers who worked on the paper believe that it can be somewhat generalized to the entire American population. And why not just go ahead? Like, just generalize the entire world's population now, don't we? Why won't we? The consequences of these decision-making errors can be something as small as forgetting to wear a hoodie or forgetting to bring your umbrella. Although, pro tip, if you're in the Netherlands, don't get an umbrella, invest in a raincoat. The winds here are strong enough to blow you and your umbrella away. Trust me, this is one pro tip from one expat to another. So it could either be as simple as forgetting to bring your umbrella or to wear a hoodie, to something as large as not doing crop protection and flood prevention procedures that can have a massive impact on your livelihood and others. And here's arguably the biggest problem, right? Your interpretation error damages your trust in these forecasts. If you were to believe that these forecasts were deterministic, and if the forecast fails, then you will lose trust in these forecasts. Meaning that next time a forecast is made, you will be less likely to trust it, and that means you will also be less likely to take the necessary precautions, which can have devastating consequences. It's boy who cried blizzard. And arguably, this messaging between the scientific world and non-scientific world is why we're in the middle of a climate misinformation crisis. But there is a way to work around this. Do away with these numbers entirely and switch to iconography that just tells you what you need to do. Should I get a raincoat? Should I get an umbrella? Should you get sunscreen? Should I wear a hoodie? Just tell me what I have to do, man. Because again, thing happening is not as important as me knowing what to do because thing is happening. I have to be prepared. So ultimately, we might not ever need to look at probability of precipitation or chance of rain ever again. Just emojis to tell us what to do on whether or not we're supposed to prepare for rainfall. Okay, I made it this far into the video without drenching in rain, so I think I'm gonna head back home right now. I hope you liked this video. I hope you enjoyed watching this video. I hope that this video was informative. If it was, give this video a big old like and share it with other people so that they don't end up under-preparing for the next blizzard. But ultimately, thanks for watching, and I'll see you in the next one. Keep getting ambushed by dogs. I can't make this f***ing video.